Okay, number 32. The legs of an isosceles triangle have lengths x plus 1 and negative x plus 7. Base has a length of 3x minus 3. What's the length of the base? Okay, so isosceles triangle means two of the sides are the same. Two of the angles are also the same on isosceles triangles than those two, but that's not really going to matter because the legs are these right here. That's x plus 1, negative x plus 7. It says the base is 3 times x minus 3. What's the length of base? Well, we know those sides are equal, so I set up an equation. X plus 1 equals negative x plus 7. Put 1's in front. So plus 1x plus 1x. So 2x plus 1 equals 7. So 2x equals 6. And x equals 3, but that's not the question I was being asked. It says find the length of the base. Well, it's 3 times x minus 3, so I know that x is 3. So 3 times 3 is 9. 9 minus 3 is 6. So that's why B has been marked as the correct answer. 33. The givens have been labeled to us. Do we have any common sides for the two triangles? Yes, we do. Now, they've already told us those sides are congruent, so I make boom, boom. You have any vertical or kissing angles? No, we don't. You have an isosceles triangle? Why, yes, we do, because we have two sides. So I know that 46 and 46 right there, because if those sides are equal, it's what an isosceles do. The opposite angles are congruent. Any supplementary angles? No, not really. I mean, I have these, well, no. These are supplementary, but it doesn't do me any good because I don't know what that is. Those two. Straight line between them. Okay, so how many congruent angles do I have? Just those two. Okay. All right, so time to find the values of x and y right here. Okay, well, I know two sides of the angle, so if I know that's 46 and that's 46, I can take 180, because it says if I have two sets of congruent angles, which I do, I know two of the angles, I can take 180 minus 46 minus 46, and I get a calculator here. As soon as I know two sides, I can get that third side. 180 minus 46 minus 46 is 88. So that makes this entire angle, the entire angle is 88 degrees. But then it's been cut into two congruent angles. So what I do is I divide 88 by 2, that's 44. So I know I've got 44 and 44. So y equals 44. So get rid of the ones where y is 46 because that's not true. So now if I just take this triangle, I know this is 46 and that's 44, so I'm able to find this because I know that 180 again. Use your rule of 180. Minus 44 minus 46. Gives me 90. Okay, so this is my answer. X is 90. So remember the rule of 180. That's important to know. I'm going to add it to our little game plan. Means if I know two angles in the triangle, we can get the third. Okay, number 34. If in an A-frame house, the two congruent sides extend from the ground to form a 34-degree angle at the peak, what angle does each side form with the ground? Okay, so the peak means 34 degrees, and these sides are congruent, means it's isosceles, so these two angles are also congruent. So I can use the isosceles triangle things in the rule of 180. So 180 minus 34. So 180 minus 34 is 146. So I have 146 degrees left amongst these two angles, which I know are congruent. So I divide that by 2, and that's 73. Okay, so that's C. Find the value of x. The diagram's not the scale. Okay. All right, so the diagram's not the scale. So it's one triangle, so there won't be any common sides, no vertical angles. It is isosceles, so I know that that's 5x minus 30. So the first thing I could do maybe is set those equal to each other. But this does me no good because I get an invalid equation, okay? Okay, so that's worth a try. Now, do you have supplementary angles? Well, yes, you do. These two are supplementary because they form a straight line. So if that's 5x, that'll be 180 minus 5x. And I know those are congruent, so let's try to write that equation. 5x minus 30 is 180 minus 5x. So I add 5x to both sides, so 10x minus 30 equals 180 plus 30, so 10x equals 210, divide by 10, and x is 21. And I was only being asked to find the value of x, so letter B is the answer. Again, go through your list of things. Isosceles I had, but just putting a 5x minus 30 and setting them equal gave me an invalid equation. So then what I did is my supplementary angle theorem when I take 180 minus 5x, and so forth. Okay, the octagon and the figure's equal angle. It means all these angles are the same. There's 8 angles because an octagon has 8 sides. Segment AB is congruent to segment AC. Okay, so I'm going to mark that for you. Find the measure of angle ACB. So ACB is right here. Again, isosceles means those sides are congruent. Now, so, any common sides? No. Well, yeah, right here, but I've already kind of have that marked, I think. Any vertical kissing angles? No. Isosceles, I've already dealt with that. Now, I have supplementary angles here, but I don't know what that is right there. If I knew how much that was, I could take it minus from 180 and find that. And that's going to be the same. Okay, you need to know how to find out what all the angles in the octagon equal. And there's a way to calculate that. First, find the total degrees of the angles, and that's found with the formula n minus 2 times 180. N being how many sides we have, so it's 8 minus 2 times 180, so that's 6 times 180. 180 times 6 is 1,080 total degrees. Now we need to split that equally into the 8 angles. So divide by 8. That's 135 degrees. So now I know that that's 135 right there. That's the one I want to know. And now I can use the supplementary angles by taking 180 minus 135. That's 45. So 45. And now I know those are congruent, so that would also be 45. So that's why letter B is the answer. The hypotenuse leg theorem. Let me explain what that is. It means I have a right triangle. Across is always my hypotenuse. And we'll say those are congruent. If those are congruent and one of the other legs, which means one of the other sides is congruent, then the triangles are congruent. That's called your HL theorem. Okay, which could we prove the triangles are congruent? Well, across from the right angle is my H. That's a right angle too. That's an H. But I don't know that those sides are congruent, so we can forget about number 1. Across from that's your H. Across from that's your H, but I don't know that those are congruent, so we can forget about number 2. Okay. There's my H. There's my H. Those are congruent, so that's good. Now, is one of the other legs congruent? Well, yeah, because they share the same common side. So they each have a side and the hypotenuse congruent, so it's 3. Is there enough information to conclude the two sides are congruent? Okay. Remember what we're doing. Look at all the things we have. Any common sides? Yep, right here. We need to use 2 because they're already using 1 to say that those are congruent. You have any kissing angles? No. You have an isosceles triangle? Yeah, but those angles have already been marked as congruent. Any supplementary angles where we have a straight line with a line right? No, not really. And if I have 2 sets of congruent angles, the third are congruent. Oh, I actually have that, okay? Because I have this set's congruent, and then I can mark this set as congruent with 2 arcs because we're using the right angle for 1, so we can do 2. All right, so what do I have here? Remember, 3 angles. Just because they have 3 angles doesn't mean they're congruent, okay? So, I have angle, angle, side. And that would be my congruency statement. I got an angle, angle, a side. You also have a side angle, side. Either one of those is good, but that's not what they're asking, okay? So yes, the answer is yes, they are congruent. Now, here's what you want to do. Just put those first triangle, put the letters in any order. Which is congruent to A? Well, it's just another A. What's congruent to B? Well, it's D. And then what's congruent to C? Well, it's just another C. Okay? So A has to match with A, B with D, C with C. Well, here C doesn't match with C, so that's out. A, does A match with A? Yep. Does B match with D? Yep. Does C match with C? Yep. It's B. So when you see, you have to provide the statement. Put one of the things down and then put the congruencies in the same order, the congruency angles. Number 39. RQ is a perpendicular bisector to PS. Okay, so PS is there, and then we got at Q, R. So it's a bisector, those are congruent. And then we complete the triangle. Angle SPR is so where it's SSPR is right there, P's in the middle, is congruent to PSR, so PSR. But which of the 5 congruent statements can you conclude that that's true? Now let's look at some of the other things. We have any common sides? Yep. Any vertical kissing angles? Not really. This is an isosceles triangle because I have 2 angles that are congruent, so then therefore these sides are congruent. And it says that's a perpendicular bisector. I missed that. So if that's perpendicular, that's right, and that's right. They're both right. Okay, remember, now do I have 2 sets of congruent angles? And the third set can be congruent. So there's a congruent set, there's a congruent set, and then these can be congruent. What I essentially have here is I've proven that all the sides and all the angles are congruent. So all sides, and when that happens, every one of my statements works. I can make every one of my statements. So I don't know what this is. It's letter A is your answer. Because you can use any one of those postulates when you've proven all sides and all angles are congruent. Okay. What additional information allows you to prove the triangle is congruent by the HL theorem? So we have congruent angles here. We have a congruent side here that was given to us, and congruent angles. Okay, so if A is E, would that prove congruency? Okay. Erase that. That wasn't given. Okay, sorry. This is how it looked originally. Congruent, congruent. It's got to be by the HL theorem too. So A and E. Okay, so across from that, that doesn't really help me. It's got to be a side, okay? Because the HL theorem, you just take your 90 degrees in the sides, okay? So again, that's our hypotenuse, that's our hypotenuse. We know the hypotenuses are congruent because they have the 1 tick mark. Okay, and then we got to prove one of the other legs is congruent. Remember, the angle has nothing to do with the legs or the sides, so it can't be the angles. AC and DC. Yep, that works. Those are each legs, so it's got to be letter C. The reason why it's not D is this. If they say AC is congruent to BD, well, right away, you know that's ridiculous because AC is just for that triangle. BD is not really any triangle size, just this whole straight line, okay? Remember the HL theorem, the hypotenuses are congruent, and one other side. Okay, what common side do triangles GDE and HED share? Now you're getting into problems where you have overlapping triangles. So when you have overlapping, you need to take this and trace over it. Okay, so GDE. And then it's very important that you label those sides. So GDE wants to know HED, so HED. Look at the triangles. There's 2 of the same letter. What are they? DE. There's your side, or ED, it doesn't matter. That's why A is the answer. Okay, what common angle do CDG, so CDG's here. And then put the letters down. And then FCE. Which one letter is common to both those? C. Okay, so that's A. I'm skipping 43. I'm going to come back to that at the end. Okay, 44. Which overlapping triangles are congruent by the ASA theorem? Okay. Hold on here a second. Hold on a second. I'm going to stop.